Okay, so we left off here. We were going over looking at graphs and figuring out their domains and range when all of a sudden the screen disappeared. Okay, so we had done this one here, the upside down parabola, and we looked at the domain. The domain are the x values. So these are the x values, and the range are our y values. Okay, so we're going to take a look at this next graph. This one is what we call a piecewise function. So let's go ahead and do a few tick marks this way, a few this way, and same thing with up here and down below. Okay. All right. I'm going to start over here at -2, -1. Okay. And I'm going to start with an open circle at -2, -1. Okay. And then I'm going to draw a line that goes all the way up to 0, 3, which is going to be over here. And I'm not going to have an open circle. I'm going to have a closed circle. Okay. So go ahead and draw that. Okay. And then my line is going to go down to 2, 1. Okay. So it's going to do this. Okay. And then it's going to go from there all the way to 3, 1. And I will do another open circle. Okay, so here, when we talk about the domain, we're going to have it in pieces, okay? All right, so over here, when we look at this, we might have it in pieces, we might not, depending on what we have in between. Okay, so over here, we don't have any, you know what? It's going to be more interesting if well, never mind. Okay, so let's just stick with this one. All right, so when we look at the x values that are being used, we're using everything from -2 all the way up to 3, but not including those, right? So here, let me do it in red so you can see it. So again, the domain are our x values. So we're looking at from here all the way to here, right? That's going to be our domain. All right, so from there to there. So when we were looking at the x values that are being used, we're using on the left, we're starting from -2, but we're not including -2. So I'm going to use parentheses. And then I'm going straight through. It's not broken, and I'm going straight through to +3. And also, that is not included because it's an open circle, so I will also use parentheses here. Okay. Now, when I take a look at the range, and I'm looking at the y values, okay, so here, the y values. So I'm looking from here all the way up to here. That's my range. Okay. And every y value between there is being used, even though I have these open circles. So down below, -1, but -1 is actually open circle. So I'm going to use, let me go back to black. So I'm going to use parentheses at -1, and it goes all the way up to the highest point, which is 3, +3. And it is a closed circle, so 3 is part of the range. So I will use a bracket. Okay. All right. So again, you're looking at the graph and you're checking to see, okay, well, what x values are being used? That's your domain. And what y values are being used? That's going to be your range. Okay. So x values for domain, y value for your range. Okay, so let's take a look at evaluating functions. Okay, so suppose that I have a function, and suppose that function is defined to be this: f of x equals x squared plus 3. Okay, and suppose that you are asked to find these values. We're going to take a look at f of 2. Okay, we'll take a look at f of -3, and we'll take a look at f of 4 minus f of 1. Okay, so we'll take a look at these three and then one more. But let's start off with this example A, f of 2. So f of 2, that basically means to substitute 2 in for x, for all the x's. Okay, so I'm going to take that 2 and I'm going to plug it into the function. So I'm going to replace all the x's with 2. And this is what I get. And now I will work this out. So I get 4 plus 3. So my answer here is 7. Okay, so make sure you understand that this here does not mean f times 2. That is not a multiplication. This is function notation, and it's asking you to take that 2 and evaluate the function at that x value. Okay, so over here, letter B, I would go ahead and replace the x with -3. So I'll do -3 squared plus 3. Okay, so here I get 9 plus 3, which is 12. Okay, so all I'm doing is plugging in the number into the function right there. Okay, now this part over here, so we have two parts, f of 4. So that means in this first part, we are going to replace the x values with 4. So let me break it up. I'm going to group this part. So 4 squared plus 3. That's this first part, right? And then I'm going to subtract this part, f of 1. So I'm going to replace the x values with 1. So I get 1 squared plus 3. Okay? So inside here, I get 16 plus 3. And in here, I get 1 plus 3. So over here, I get 19 minus 4. And so I get 15. Okay? So evaluating is just taking whatever it is inside the parentheses there and replacing all the x values with it. Okay? All right. Now let's take a look at a little more complex one. But so long as you stay organized, it shouldn't be too bad. Okay, now suppose that I want to find this, f of a plus h. Okay, so again, whatever's inside here, inside the parentheses, that's what you want to replace all the x's with. So just like in example A over here, 2 is inside the parentheses, so I replaced all the x's with 2. Over here in example B, -3 is inside the parentheses, so I replaced all the x's with -3. And then over here, first I replaced all the x's with 4, and then I replaced all the x's with 1, and then I subtracted those two answers. Okay, now here in example D, a plus h is in the parentheses, so that's what I need to replace the x with. So I'm going to replace the x with a plus h. So it's going to be a plus h quantity squared plus 3. Okay. And hopefully you know how to multiply this binomial out quickly using the shortcut. So if you don't know how to do that, you're going to have to go off to the side and work that out, FOIL that all out. Okay. But you should be able to do this in your head and get 2ah plus h squared. Okay. And then bring down that plus 3 as well. Okay, if you're not sure how I got this part, then you're going to have to go off to the side and do it the long way, which is not too bad. And you have to do your distributive property. A times A is A squared. A times H is AH. H times A is, I'm going to say AH. H times H is H squared. These two are like terms, so you get A squared plus 2AH plus H squared. Okay, but you really should know the shortcut to multiplying out a binomial. Whenever you have this squared, it's going to be whatever that first term is. Okay, I'm going to make this symbol instead. So that whatever is in that first term, that's what gets squared. Okay, plus 2 times whatever is in that first position and here, and then plus whatever is in that y spot, that gets squared. That's the shortcut. So if you didn't know that, try to memorize this. Okay, so here, let's do another one down here. So if you have this 3x plus let's do 5 quantity squared. Okay, so according to that formula, that structure, you're going to take the first term 3x and square it. Okay, I'm not even going to write that. I'm just going to erase that. Okay, so you're going to square this first term, because that's what this says, square that first term. So we get 9x squared. And then here, that middle term, you're going to multiply both of these inside. So I get 15x. 15x, but then double it. So that's 30x. And then to get this third term, you square that last term. 5 times 5 is 25. Okay? So that's how you do that. Try to memorize this. Okay. All right. So when you get an example like this one here, f of a plus h, again, you just replace all the x's with whatever is inside the parentheses. So I replace the x with a plus h. I work that out. Knowing this here is going to be helpful if you plan on going into calculus after this class. It's going to save you a lot of time knowing how to do that. Because what's going to happen is they're going to say, okay, well, hopefully you can do this kind of a problem. So then they're going to ask you to do this kind of a problem, not just a plus h, but then they'll have you subtract. So they're going to start, making them a little bit more complex. Okay. And yeah, this is not too bad. We just did that one. This one, you would just replace all the x's with a. Okay. All right. Moving on. Okay, so let's take a look at graphing. I'm just going to look at a few basic graphs. And then when we go into the next section, when we start looking at shifting, doing transformations with graphs, then we'll get a little bit more into them. Okay, but you do need to know like the basics. Okay, so one way to graph is by plotting points. Okay, so we looked at that with lines in the previous section. So if you have this function, a linear function, so like 3x minus 2, you can plot points. You can make a table, or you can use the shortcut that we learned. So here, if we decide to make a table, let's suppose we don't remember the shortcut on the day of the test. You can always make a table of values. We can choose 0, 1, negative 1, and plug those in. 3 times 0 minus 2 is negative 2. 3 times 1 minus 2 is 1. Negative 1, we get negative 5. Okay. So 0, negative 2, 1, 1, and negative 1, negative 5. 1, 2, 3, 4, and 5. Okay. And we get this line. Okay. We're going to do this for a few more graphs because these are going to be important when we do the next section. So let's take a look at this graph. F of x equals x squared. Okay, very basic graph. Again, we'll take a look at that more in the next section. So here, I'm going to go ahead and make my table. And 0, 1, negative 1, also good to choose. So when x is 0, we get 0. When x is 1, we get 1. When x is negative 1, we plug that in. And we also get positive 1. So we get 0, 0, 1, 1, negative 1, 1. Okay. So if you're wondering how I got this table, let me go here. Let me erase these. So I got the table. You can choose random numbers for x. Okay, 0, 1, negative 1 is a nice set of numbers to choose because you get 0, that's easy. 1 is easy, and then negative 1 kind of represents the negative side. So 0, 1, negative 1 are all nice, easy numbers, and it's a good sample. Okay, but you don't have to choose these three numbers, 0, 1, negative 1. If you want to choose 1.78 as your x value, you are more than welcome to. All right, and then you just take these values right here, right? And all you do is plug them in to the function, okay? So when I take that 0 and I plug it in here, I get 0 squared, which is 0. Do the same thing with 1. Plug it in here. 1 squared is 1. Negative 1, plug it in here. Negative 1 squared, negative 1 times negative 1 is 1. Okay, so I get these 3 points that we already plotted, and we get not a v. X squared is a parabola. Okay, so if you see x squared, you know you're going to get some sort of a U shape, not a V shape. Okay, absolute value is the V shape. Okay, so make sure that you know these 3 standard points on this graph of the parabola for the next section. All right, let's take a look at x cubed. Okay, so this graph, important for you guys to know the 3 standard points, because these are all what are called parent functions. So it's important that you know the basic shape of the graphs, and it's important that you know the 3 standard points for these parent functions. Okay, so like for here, lines are easy. So like x squared, make sure you know these 3 points on the graph: 0, 0, 1, 1, negative 1, 1. For the x cubed graph, so again, 0, 1, negative 1, nice numbers to choose. Plugging in 0, 0 cubed is 0, 1 cubed is 1, negative 1, what's negative 1 to the 3rd power? Anyone? Anyone? Okay. Did you say -1? Good. All right, so here we have a point at 0, 0, 1, 1, -1, -1. Okay, so it looks like it's going to be a line, but it is not a line. Okay, lines, linear equations do not have exponents. We have an exponent of 3. We get more of like a snake. So here we have a graph that looks like this. Okay, so very important that you know, again, these 3 standard points on the graph and the basic shape. Okay, let's take a look at 2 more, the absolute value graph and the square root graph. All right, so here f of x equals absolute value of x. So here also good choices, 0, 1, -1. When we plug in 0, we get 0. When I plug in 1, I get 1. When I plug in -1, remember, absolute value is always positive. So the absolute value of -1 is 1. Okay. And so here I have a point at 0, 0, 1, 1, and -1, 1. Okay, so this very similar to this parabola, right? We get the same points, 0, 0, 1, 1, -1, 1. But this one, so x squared is the u, absolute value gets the V shape. Okay, that's kind of, that might be easy to remember because remember, this is absolute, and then this value, V for value, absolute value. Okay, so make sure you know those 3 points. And then this last one here, f of x equals square root x. Okay, so here I'm taking the square root. So we don't want to take the square root of a negative number because then we end up with imaginary. So 0 is still a good choice. 1 is a good choice. -1, not so much. Okay, so I'm not going to choose -1 as my third point. I'll choose 4. Why do you think I chose 4? Because it's a perfect square. Okay, you can go ahead and choose 2 if you want, or 3. But I'm going to choose 4 because square root of 4 is 2. Okay, all right, so square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Okay, so 0, 0, 1, 1, and 4, 2. So what actually happens here is you can't really tell from these 3 points, but what you actually have here is like the top half of a sideways parabola. So if you can imagine a parabola, but because we only take half of it, the positive half because it's square root, it's like a sideways parabola, but only the top half. Okay. All right. So these are your parent functions, and we're going to focus heavily on the parent functions in the next section. So very important that you somehow memorize the shapes and the 3 standard points. They're kind of easy to come up with in your heads anyway, but you know it needs to be automatic before you look at the next lecture video. Okay. Okay. So those are going to be some basic functions there. Now let's have a look at some other functions to consider. We're going to look at the piecewise function right now. And then after the piecewise functions, we'll look at the greatest integer function, and we'll be done. Okay? So piecewise function. All right, so sometimes we use these functions, we use these equations to model behaviors. So whether it's bacterial growth or the spread of a virus, or the way a particular stock behaves, or things in business, we use equations, we use functions to model the behaviors so that we can make predictions. Sometimes one equation is not enough to model the entire behavior of something. So maybe something starts to rise. Okay, so like maybe the cost of oil. Okay, so maybe it starts to rise and then it plateaus, right? And then it starts to go down. Same thing with a virus, right? So the spread of the virus or the infection rate. Maybe it starts to increase, and then we start to pull back and we start to do the stay-at-home orders, and so then it starts to flatline, and then we continue to do the stay-at-home orders, and everything is closed, and then the numbers start to dip down. We don't have a single function to model all three of those behaviors: an increase, a plateau, and then a decrease. Okay, so that's where piecewise functions come into play, because here you can define or you can model the behavior using more than one function. Okay, hence the name piecewise. It's going to be several pieces. Okay, so defined by different formulas on different parts of its domain. So the graph consists of separate pieces. Okay, so here is an example. Suppose that I have this function. So I can't define the behavior with using one function, so I'm going to use two. I'm going to have f of x equals 1 for part of the graph, specifically for the x values that are less than or equal to 1. And then I'm going to use this one, x plus 1, specifically for the x values that are greater than 1. Okay? So if you recall, right here, this first function, y equals 1, that means that's all the y values are the same. So it's that special case line. So it's going to be a horizontal line, right, for x values that are less than or equal to 1. And then over here, this is a line with a positive slope. So then it's going to climb. Okay. So it's flat line and then it climbs. Okay. So let's take a look at evaluating. Okay, so let's use f. Let's find out f of 0. Okay, so we take a look at this x value, 0. And then we decide, well, which of these two does 0 fall? So 0, is 0 an x value that's less than or equal to 1? Or is 0 an x value that's more than 1? So clearly it's a number that's less than or equal to 1. So we are going to use this first function to evaluate. Okay, so there's no place to plug in an x, so we just get 1. Okay, So here we use the first function. Since 0 is less than 1. Okay. Suppose that I want to evaluate f of 3. Okay. So again, this number 3, is that a number that's less than or equal to 1 or greater than 1? That's a number that's greater than 1. So we are going to use the second one, right? So we're going to use the second function since the number 3 is greater than 1. Okay? So using the second function, that's this one over here, I plug in 3. So 3 plus 1, and we get 4. Okay? And what about this last one, f of 1? Which of the two am I going to use? The first one, the top one, or the second one, x plus 1? Okay? Which one? F of 1. So this 1 is 1 less than or equal to 1, or is 1 greater than 1? It's less than or equal to 1. So we're going to use the first. We're going to use the first one since 1 is less than or equal to 1. And again, there's no place to plug in for x, so we just get 1. Okay? So that's how you would evaluate the functions. You have to decide whatever number is in here, whatever number is there, you have to see how it fits in over here. Okay? If it's a number that's less than or equal to 1, then you use this function. If it's a number that's greater than 1, then you use this one. Okay? All right. And then let's go ahead and take a look at the graph of that piecewise function. Okay, so we're basically graphing y equals 1 and y equals x plus 1. Okay, and we're transitioning from one graph to the other graph at x equals 1. Okay, so right over here, this is where it's going to change. So y equals 1. This is for x values less than or equal to 1. And this one is for x values greater than 1. So all these x values to the left of 1, here's 1. All the x values to the left of that is going to get this first graph, okay, which is y equals 1. That's the horizontal line, okay? So it looks like this. And at 1, it's going to stop. It goes on forever that way, but it stops right here. Okay. Now, starting from there, we're going to use this graph. So that graph, well, you can plug in numbers. When x is 1, we get 2. Okay. But that one is going to be open circle because remember, 1 isn't part of our domain for this function. So it's going to be open circle. And then when I plug in 2, I get 3. So I only need 2 points to draw a line. And this one goes on forever that way, but not the other way. Okay? All right. So that's how you graph up piecewise. Remember, this is where the transition happens. So the graphs have to not go on beyond that point, okay? All right. There's another interesting function called the greatest integer function. So this is our last one, and then we'll wrap it up. Okay, so maybe you've seen this before, maybe you have not. So it looks like this. Okay, greatest integer function. So that's what this is, the greatest integer function. And this is going to be equal to the greatest integer less than or equal to x. Okay? So here are some examples. So the greatest integer for 2 is going to be 2. The greatest integer for 2.3 is, so remember, the answer has to be the biggest integer, but you can't be more than this number, 2.3. Okay, so it's got to be 2. Okay. 2.7. Same thing. It's still going to be 2 because you can't be larger than 2.7. Okay. 3.1. Okay. It's got to be 3. Okay. 1.9. Okay. So it's got to be 1 because you can't be larger than 1.9. Okay. And this here, negative 4.2. Okay. Negative 4.2. That is going to be negative 5 because you can't be larger. Remember, negative 4 is actually larger than negative 5. Okay. All right. And the way this graph looks, it looks like this. All right. So for all the x values between 0 and 1, you're gonna be at 0, 0.1, 0.2. Okay. And then you stop right there, open circle. And then all the numbers between 1 and 2 will have the value of 1. And then all the numbers between 2 and 3 will have 2. Okay. All the numbers between 3 and 4 will have 3, etc., etc. Okay. And then over here, so all the numbers in between 0 and negative 1 are going to have negative 1, open circle. Okay. So remember, it's closed on one end, open on the other, because this is still a function, and the number, like say here at 1, can only have one value, right? According to the definition of a function, every x value can only go to exactly one y value. So it can't go to both of these here. It can only go to this one, okay, not that one. Okay, that's why we have open circle, and then top is closed circle. Okay. All right, so we call this a step function. These are just some functions you'll need to know about, but that's basically it. As far as what you really need to make sure you have down for the next section, again, these basic graphs right here, these parent functions. Okay, make sure you have these parent functions down for the next section. Okay, that is it. So again, if you have any questions, make sure you message me. We could always schedule a Zoom office hour if you need to. Okay, if you want me to look at your work or if you want me to go over some more examples of things, just message me, email me. Until then, I will see you next time.